Hello students, welcome to GradeGuru. In this video, we are going to dive into a very important topic in chemistry, which is how to find the number of molecular mass. What is molecular mass in the first place? Well, molecular mass is the summation or the equal of all the atomic mass that is contained in a molecule. So when we add all these atomic masses together, what we essentially get is a molecular mass. Now, what exactly is molecule? Well, a molecule is where all these atoms are contained. So when we have a group of atoms together, we call it a molecule instead of calling it atoms. Okay, this will be a lot more easier when I explain it in this way. Okay, so let's say we have box A and then we have box B, and then we put them together in box C. Now, what is going to be the total mass of this box C? Well, it's going to be A plus B equals to C, right? So what about, let's say we put 2 of A. Now what is going to be the mass of the C? Well, it's going to be 2A plus B plus C. We can also explain this putting some numbers here. So let's say A is 10 kilograms. So we have 2 into 10 plus B. Let's say this is 5. Well, that becomes 20 plus 5 equals to 25. Now what I'm explaining is, well, this is exactly how an atom works, or the molecular mass. What we mean is that, let's say we have atom A and then we have atom B, and then together they become a molecule, which is C. So now when we have to find the molecular mass of C, what we need to essentially calculate is the atomic mass of A and then B. Now, if we have 2 of A, then we have to take that into account as well. If we have 2 of B, we also have to take that into account. Now, this will be a lot more easier when we explain with some examples. So we have carbon dioxide here. What we have to find is the molecular mass. So what we first do is we have C plus O2. Now, what is the atomic mass of carbon? It's 12 plus. What is the atomic mass of oxygen? It is 16. Now, be careful. We have 2 here. We have to take that into account. So this becomes 16 into 2, and that gives me 44. Now, let's solve another example. So we have sulfur dioxide. We have S plus O2. Now, what is the atomic mass of sulfur? It's 32 plus the atomic mass of oxygen is 16 into, again, 2. So that gives me 64. It's pretty easy, right? Well, let's solve another one. We have Fe2O3. So we put Fe2 plus O3. Now, what is the atomic mass of iron? It's 56. Since we have 2 of that, let's put into 2 plus oxygen. Since we have 3 of that, we put 3. And that equals to 160. Okay, another one. H2SO4. So we put H2 plus S plus O4. Okay. So what is the atomic mass of hydrogen? It's just 1. Since we have 2 of that, it's 1 plus 2. Now for sulfur, we have 32. For oxygen, we have 16. Now since we have 4 of that, we put into 4. And that gives me 98. Okay, now let's try to solve this. This looks a bit complicated, but it really isn't. So we do the same thing. Do Fe2 plus SO4 into, we'll do that 3. So we kind of separate this. So if we do that in that way, what happens is this becomes 112. This becomes 96. And then since we have 3 of that, you see, it's 3 of that. So we just put into 3. And that gives me 400. Okay, so finding the molecular mass is pretty easy, right? Now, what we will learn is how to find the number of neutrons or the number of protons or the number of electrons in a molecule or a compound. So let's start with sodium chloride. What we need to find is the number of protons, neutrons, electrons. Let's put sodium here, and then we put chlorine here. So what is the number of protons in sodium? Let's see. It's 11. What's the number of protons in chlorine? Well, it's 17. So what is the total summation? It's going to be 28 protons. So what I'm saying is that how many number of protons are there in sodium chloride? Well, it's 28. 11 comes from sodium and 17 comes from chlorine. Likewise, you can also do it for neutron, and the electron. Now, I'll help. This one should be solved by you. And for the electrons, well, since we know the number of protons, the number of electrons is always same as long as it's not charged. So as we can see, there is no charge here. So this is going to be 28 as well. Let's do for H2O. Okay, so we put H2 and then we put O here. So what is the number of protons? Well, it's going to be 2 because each contains 1. And what is the number of protons for oxygen? Well, it's going to be 8. So in total, we have 10 protons for H2O for water. So now we have for neutron. Well, what is the number of neutrons for hydrogen? Well, it's a bit confusing, right? Because it's H plus 1 and 1. Well, it's actually 0. Hydrogen does not contain any neutrons, so it's going to be 0. So be careful on that. And oxygen, it has 8, so this is 8. Electron, well, we see it's not charged. We don't really have to calculate this because we know that the number of protons and the number of electrons is going to be the same as long as it's not charged. So it's going to be 10 as well. Okay, now let's solve that is charged. So we have 2 minus here, so we have to be a bit careful. We will find the number of electrons here. I will let you do it, the protons and neutrons, because you can solve that as I've shown before. And it's always important to keep in mind, whenever we see charged, okay, the number of protons and the number of neutrons, they don't change. What essentially changes is the number of electrons. I repeat, it's the number of electrons that changes when it is charged. Okay, so let's do this. So what we have here is the number of, let's put C and then we put O3. Okay, so what is the number of electrons in carbon? It's 6. What is the number of electrons in oxygen? It's 8. But since we have 3 of them, it's 8 into 3. And then what we do, we have a charge. So we have to, if you remember, E equals to Z minus C. What is Z? Well, we already have calculated this. Z is the number of protons. But now, this is where it becomes a bit challenging. We have to put minus, and then since it's also minus, it's minus 2, so it becomes plus. So what is the summation of these electrons? It becomes 32. Okay, let's do another one. Again, we will find the number of electrons, and I would leave you to find the number of protons and neutrons. So let's do it. S2, we have O7, and then we have 2 minus. Okay. So this one, it becomes 32 in total. Okay, so because each sulfur contains 16 electrons, so we have 2 of that. And similarly, in total, we have here 56. Now, this also becomes plus 2. So what is the total number of electrons? It's 19. Let's do another one. Here we will find the number of protons. Okay, and also the electrons. Okay, so kind of really know what's happening here. So we have S, we have O3. So what is the number of sulfur here? For protons, it is 16. What about oxygen? It's 8 into 3. And then, oh, there's charge. What do we do with the proton? Well, we ignore that. So this becomes 40. Now, if it was not charged, the number of protons and the number of electrons would also be 40. But since it is charged, we have to take that into account. So it's going to be 40 minus 2. Where do we get this equation from? Well, it's again Z minus C. So this becomes 42. Okay, so that was pretty easy. Now, what about if we ask, okay, find the number of electrons in a molecule, or the other way around. How many electrons does a molecule contain? Let's see. So let's say we have five molecules of CO2. find the number of electrons. How can we find that? Well, if we know the number of electrons in one molecule of CO2, which is 22, and if we need to find the number of electrons in 5 molecules, we just do this. So 22 into 5 is 110 electrons. Now we could also do it the other way. Let's say we have 110 electrons. Find the number of molecules of CO2 in here. So what we do is just, because 22 electrons is contained in one CO2, and then we find out that this is 5 molecules of CO2. So as you can see, it's actually pretty easy. Okay, let's solve another one. Let's say we have 1800 electrons. Find how many H2 is inside. Well, we know one H2 is 18, right? So 1800. Sorry, if we are calculating the number of electrons, the number of electrons in H2O is actually 10, not 18. So we do divided by 10 into 180 H2O molecules. Now, what happens if we are dealing with the neutrons? Okay, so let's say we have 1800 neutrons now. How many H2O is inside? Well, now we have to find the number of neutrons in one H2O, which is 8. So this gives me 225 molecules. Okay, that was it. I hope this video was helpful, and if you found this video engaging and helpful for your further study, please do give it a thumbs up and share it with your friends, and don't forget to subscribe so I can give you more easier to follow chemistry videos. Thank you for watching.